So just to reiterate for those who are on tournament, the transversal is the line that connects two or more lines. They can be parallel, they don't have to be, but it's called a transversal. When you have a transversal, there are special names for different relationships between the angles that are made. Okay, your book does something really fun in saying corresponding angles are in corresponding locations, which is a terrible thing. Those of you who are good in English know that you never make a circular definition like that. So I've borrowed from another textbook that I used years ago to get a better explanation as far as what these things are, okay? Because just saying corresponding angles are in corresponding locations doesn't tell you anything. All right, so first of all, corresponding angles are on the same side of the transversal. So if this is the transversal, they would have to be, so an angle that would correspond with one would have to be on the same side as where one is. They also have to be non-adjacent. That means they can't be next to each other. So 1 and 3 can't be corresponding angles. The angles that are inside between the two lines are called interior ones, and the ones that are outside are called exterior ones. So the last criteria is that you have to have one interior and one exterior. So for example, angle 1 is corresponding with angle 5 because it's on the same side of the transversal, it's not right next to it, and 1 is in exterior and 5 is interior. So 1 and 5 are corresponding angles. Based on that definition, does anybody see another pair of corresponding angles? Abby? 2 and 6 would also be corresponding angles. So 2 and 6 are also corresponding angles, and I think, Jordan, you wanted to give me some as well? 3 and 7 are corresponding, and then there's one more pair. Anybody see it? 4 and 8. Good. So here's our list of them in case you didn't follow that. 1 and 5, 2 and 6, 3 and 7, and 4 and 8. Those are what we call corresponding angles. We're going to have a lot of information about these types, so you need to know what the relationships are in order to understand about them.
Shut up. You shut up. You shut up. You shut up.
Boys.
Stop being mean to me. Hurt my feelings.
Okay.
I want him to stop.
Duly noted. Just don't play, guys. Alternate interior angles. Okay, so this is another special angle relationship. Okay, alternate means one on one side of the transversal, one on the other. Okay. They're also not next to each other, and they also both have to be interior. Okay, so 1 can't be an alternate interior angle with anything because it's exterior, it's on the outside, but 3 can. So it can't be next to it, so it can't be 4. So 6. 3 and 6 are alternate interior. What's the other pair of alternate interior in this picture? 4 and 5. 4 and 5. So 3 and 6 and 4 and 5. Okay, so you could write that down so that you know for examples. Alternate, so they're on opposite sides of the transversal, and interior and inside. Okay. Next type, alternate exterior. You kind of get to see that they have names that are very descriptive as far as what they are, except corresponding is just kind of like, okay, in corresponding locations, sure. Alternate exterior, well, they have to both be in the exterior. They can't be next to each other. So 1 and 2 can't be them. And they have to be on opposite sides of the transversal. So that would mean, here,
1 and 8.
1 and 8, beautiful. Isaiah, the other pair would be
2 and 7.
2 and 7, good. So you can write down 1 and 8 and 2 and 7. And finally, consecutive interior. And these angles will all have special relationships as far as the number of degrees when we have parallel lines. So that's where we're going with this. Okay, so consecutive interior, both on the same side of the transversal, and they're both interior. Okay, so not so many things in the list this time. Sheen, what do you think? Same side of the transversal, both interior. So what would be in the consecutive interior?
3, 6.
3, not 3 and 6. They have to be on the same side of the
3 and
transversal.
5.
3 and 5.
And then 4, 6.
4, 6. Good. Okay, good. So I think the vocabulary is going to be good for you. You just have to study a little
Wait.
bit and make sure you know what they're called.
Miss Dowdy,
Yes.
did we skip alternate exterior?
We did not.
Oh wait.
Alternate exterior would be 2 and 7 and 1 and 8.
Oh, then what was alternate interior?
Alternate interior would be 3 and 6
And 4
and
and
4
5.
and 5.
Okay.
Okay, so we have a postulate to kick us off on this. So the postulates will lead you to theorems, and all of these things can be used to find other angles or things like that. So our first thing that we're told about these things is if we have two parallel lines. Okay, so in other words, L is parallel to M. If you have two parallel lines, then the corresponding angles are congruent. So give me a pair of corresponding angles from this picture here. 2 and 6. So angle 2 is congruent to angle 6. Corresponding angles, what else is congruent? 2 and 6 are congruent. Yes. 1 and 5 are congruent.
3 and 7.
3 and 7 are congruent, and 4 and 8 are congruent. So please write this part in. Angle 1 is congruent to angle 5. Don't forget what the angle symbol looks like. Don't forget what the congruent symbol looks like. So angle 1 is congruent to angle 5. They are corresponding angles. So because it's a postulate, we can't prove it, but it will always turn out to be true that the corresponding angles are congruent. When we refer to this in a proof, we would say corresponding angles postulate. You don't have to write it all out. You could even write corresponding angles are congruent. If you don't remember the name of a theorem, you can write what it says, and that's still going to be good enough. And if you'll notice there, on the next thing is we have a little proof that we need to handle. Okay. Now I'm going to actually put this one on the, no, I won't put it on the board. Never mind, they can't see if I put it on the board. So what I'm going to do is on this proof, I'm going to actually copy it. And I'm going to paste it into a, make this happen from here. And it gave me a new sheet, but it gave me the new sheet over here. Drag it. And I'm going to paste that on there. There we go. So we're going to work through this proof together. A little smaller. Let's see. Okay, so from your past relationship with proofs, what do you think is going to be the very beginning of our proof?
Given.
Given. And what is given specifically on this? What's given to us?
What is that? I don't know that. 11M?
This says L. What's this mean?
Parallel.
L is
Oh.
parallel to M. Because if we don't know that we have parallel lines, then we can't know anything about their angle relationships. Okay, we're trying to prove that angle 1 is congruent to angle 8. Okay? So we want to work our way through with something that we know. We have only one fact so far about parallel lines. What is that one fact that we have that we just wrote down? We're just talking about it.
That the corresponding angles are congruent.
That the corresponding angles are congruent. Now we're dealing with angle 1 and we're dealing with angle 8. So pick one of them and use that idea. So for example, angle 1, if you're thinking about that fact, angle 1 is congruent to what angle?
8. I mean 7.
1,
Oh, and 5.
1 and 5. Angle 1 is congruent to angle 5. And what did we just say would be the reason that we know that angle 1 is congruent to angle 5?
Because all corresponding angles are congruent.
Good. Corresponding angles are congruent. So you can say corresponding angles postulate, or you can write corresponding angles are congruent.
Wait. Yes, Debbie?
Yep.
What is flatland?
Don't worry about flatland. I'm going to start flatland on Monday because I want to have our soccer players back and talk to everybody at one time. Flatland is going to be a little tiny book that we're going to read. I'm going to spread it. It is very, very thin. I'll show you. It's not a thick book. We're going to read this. This is going to actually, we have what's called an exam term. So this is going to count as half of your final exam. And there's going to be specific questions for it. It is 22 chapters in this, believe it or not. So the chapters are like 2 pages long. And I'm going to give you a schedule, and it's going to be spread out over 2 quarters that you're going to get a chance to do that. So it'll be an easy 100 if you do what the questions say, because we're going to discuss them, and you'll have the opportunity to write in all the right answers. So it'll be an easy 100 if you keep up with the schedule, which would be basically 2 or 3 pages a week. I mean, it's a novella, so it's not, so it's not going to be a giant deal, but it does deal with geometry. It also deals with God, and it also deals with social issues. So it's actually a very good book, but it was written in the 1600s, so we'll talk about that. Okay, so anyway, back to this. So angle 1 is congruent to angle 5. I'm trying to work my way through so that angle 1 is congruent to angle 8. So I've now brought angle 5 into my thinking. I want to know, do you see any relationship between angle 5 and angle 8 from the last chapter?
Yeah.
What is the relationship? Do you know what it's called? They're not supplementary. I'll give you a hint. Starts with a V.
Vertical.
Vertical. They're vertical angles. What do we know about vertical angles? What's their relationship? We have a postulate. We didn't really use it, but they're congruent. So that means that angle 5 is congruent to angle 8. I'm going to tell you right now, groups dealing with pictures frequently have that vertical angles are congruent in it. We can write it out like that. If we don't remember it, if it's a postulate or a theorem, we can just write vertical angles. I can use the symbols are congruent. And I can abbreviate it like that if we want to. So angle 5 is congruent to angle 8 because vertical angles are congruent. Our last step in our proof always has to be what?
If thing we're solving.
The thing we're solving for. Okay, so it won't always have the same answer, the same reason, but it always ends here. Are we ready to say angle 1 is congruent to 8 yet? And yes, why do you think so?
I said no.
Oh, you said no? Okay. Yep. Okay, he said yes, we are, because we can use the transitive property. And that because is super important. Angle 1 is congruent to angle 8, because guess what? They're both congruent to 5. Okay? Angle 1 is congruent to 5. 5 is congruent to 8. Therefore, 1 is congruent to 8. And he gave the right reason. It's the transitive property. Sorry, I've got your spot covered up here. Actually, if you want, you can sit there. Transitive property. Technically, it's the transitive property of congruence, but if you just write transitive property, that's fine. Okay, I'm not going to nitpick as far as whether you put of equals or of congruence. This part, number 3, does need that. So my proof is done because we've made a path from what we know to what we were trying to find, and everything had a good reason for it. Yes.
We could also do substitution for number 4.
We couldn't say substitution because there's no substitution property of congruence. There's a transitive property of congruence. Substitution, it's like the substitution property. But if you see the congruent, just write transitive, because you'll know you're automatically incorrect if you use substitution for when it has a congruent in it. Okay. So transitive property of congruence because they're both congruent to 5. Okay. Everybody follow that? Oh, okay. And you have the papers there. All right. Let's go back to here. And this is what we did. This is what's called the alternate exterior angle theorem. Did anybody notice that angle 1 and angle 8 are alternate exterior angles? Okay, good. Thank you. Glad you did. Okay, so we proved what says on the next page, if 2 lines are parallel, then alternate exterior angles are congruent. So from here on out, we can use that as a reason in the proof. We don't have to prove it again. We proved it once. It was a great example of a proof, which was a nice, short, simple, friendly little proof. But we've proved that that is a fact, and we can use it then going forward. We can use it for solving problems, and we can use it for as being part of another proof. Okay, Jesus, you had asked me at some point, I don't think it was in front of the class, can you use theorems in proofs? And absolutely you can. So we're building our toolbox of different theorems, and then we can use them in other proofs. Okay, so alternate exterior angles are congruent. That's going to be a fact that you can use, and you can do them in problems. On the upper right, there are other theorems. Okay. We're not going to necessarily prove them all. Some of the theorems I'm going to say, okay, trust me, you could prove it. Okay, we're not going to prove them all, but understand that these are all facts. So you can think of them as fun facts if you need to. Okay, alternate interior angles are also congruent as long as the lines are parallel. This one is not. This one doesn't talk about congruence, but talks about supplementary. Okay, so the consecutive interior angles, I'll go back to this picture, consecutive interior angles like 3 and 5, they're not congruent to each other. In this picture, they don't even look like they're congruent, but they are actually what we call supplementary. They would add up to 180. Just like 5 and 6 would add up to 180. Anybody remember why 5 and 6 add up to 180? This is from the other chapter. Yep.
Because they form a line.
Because they form a line, because they're a linear pair. So we had the linear pair theorem. We also now have consecutive interior angles. They also make 180 degrees. Then we have this perpendicular transversal theorem. Okay. I need to draw that out for you. So I'm going to put that onto paint. Paint is a pretty simple thing, but it's very, very useful for stuff like this. This one I was working on. So you can see it. I just want this perpendicular transversal theorem. Okay, so it says if a transversal is perpendicular to one of two parallel lines. Okay, so here we've got two lines. I'm going to tell you that they're parallel to each other. You can draw this somewhere if you want to. There's not really a space for it, but I'm going to just tell you that L is parallel to M.
I'm confused. What's that little swirl?
This is just an L. It's a cursive L. Okay, so I'm just saying, I'm giving you that these two lines are parallel, perpendicular, transversal. If a transversal is perpendicular to one of two of them, so I've got two parallel lines, I'm going to draw in a transversal. Everybody look up because you need to see this happen or it's going to make no sense. Okay, so I've got this. I want to make sure it's perpendicular to one of them. So I'm kind of eyeballing it a little bit, but it's perpendicular to M. That means if I extend it up and it's perpendicular to M, it also has to be perpendicular to L. What does perpendicular mean? No, it's not perpendicular. No. There we go. Perpendicular. So what does perpendicular mean? Yep. Has a 90-degree angle. So if there's a 90-degree angle here, that means that there is a 90-degree angle here. But guess what? Those that I just drew in, what was the special word that starts with a C that besides not congruent, but the special name for those that I just marked? Beautiful, thank you. They're corresponding angles. So it just makes sense that they would be congruent. We could do a proof of it if we needed to. Okay, because we have L parallel to M, this one would be 90. They're corresponding angles, so therefore the other one will be 90. And so we can have a proof like that if we needed to. Now what these are used for, besides just doing proofs, what these are used for is for you to find missing angles. So let's take a look right here. So if we're going to find the missing angles in here, we're given one to start with. What you need to do is you need to write in angle 1 is 70. You need to write that down, put it right on your picture so that you can see it. Go back to this. And pull this down so I can plunk that right in. Okay. It used to just let me draw right on that program, but since it doesn't do that anymore, I have ways. Here we go. So angle 1 is 70. And we're trying to find all of the other ones.
Why is angle 170?
Because it's given to us.
Oh,
so we take what's given and we write it in. So that one's 70. What does that tell you about something else? Tell me one additional angle here. 2. Angle 2 is how much? 70. 70. How do you know that?
Because they're congruent.
They're congruent because what's the name of them? We're going to practice the name also.
corresponding.
Not corresponding. They are. Yes. Alternate exterior. Alternate exterior angles, and they are congruent. Can you tell me another?
7.
Wait. 1 and 2, well, they're not vertical. I don't need another name. One of the other angles and how much it is. Okay. Actually, Isaiah wants to jump in. Is that fine?
7 is 70.
7 is also 70. Good job. How do we know that 7 is 70, Isaiah?
Because it's what's the word? Is it one of the things that we just learned? One of the arterial stuff or the relatives?
Actually, it's not one of the things we just. Although, yeah, kind of it is, depending on which one you're comparing it to.
I would have to go back to my notes, but just tell me.
Okay, Miley, want to help?
1 and 7 are corresponding, and 7 and 8 are alternate interior. So 8 is 70 also.
Okay, so he said that 8 is also 70 because it's alternate interior. How did we know that 7 was 70?
Because 1 and 7 are corresponding.
1 and 7 are not corresponding, but they are congruent.
Oh, alternate exterior.
Actually, this is from the other chapter. Starts with a V. Anybody?
Oh,
Vertical.
vertical.
Vertical angle. 1 and 7 are vertical. 7 and 2 are corresponding. So 7 and 2, so it makes sense. 7 and 2, they're also equal. 7 and 2 and 8 are vertical, but these are also alternate interior, so they're equal to each other. So all these things working together. Okay, so we've got those. Now we need to consider some of the other ones. Does anybody see what any of the other ones might be? Yes.
4, 6, and 3 are 110.
4, okay, let's start with, you said 4 is 110. How did you know that 4 was 110?
Because 4 and 7 are supplementary.
Because 4 and 7 are supplementary, they make a line. 4 and 8 are also supplementary, that's another fact. So they make a line. So that is 110, 180 minus 70 is 110. Okay. And then you gave a whole string of ones that were also. Shane, can you tell me another one? This one's 110. So can you tell me either 6 or 5 or 3?
So you can say 3.
But she told me
6 or 5
Sure.
or 3?
I'll look at
Which one of them? 3 is how much?
7.
It's not 70. 3 is actually, how is 3 related to 4? What's the name of that?
Vertical. Congruent.
Oh,
We're gonna let, I wasn't saying you were wrong, I was just gonna let. They are congruent, yes, because, so it's 110. What's the name of them though? I know that Isaiah, you wanted to say the name of it.
Vertical.
no,
Or congruent.
no.
No.
Congruent, they're not vertical. What
Oh,
are
I
they
don't know.
here?
Alternate external external
Yeah.
angles.
Alternate exterior would be like 2 and 1, 2 and 1. So they're not alternate exterior. What's the name? It starts with a C.
Why is 8 7? Wait.
Corresponding. Thank you.
Wait, why is
I
8?
said that.
Why is 8?
Corresponding.
Why is
All right, I was trying to narrow in on. Okay, so I heard right answers and wrong answers at the same time. So I need to make sure. Okay, so there's that. Rick, do you know either 6 or 5?
They're both 110, right?
They're both 110. Why is 6 110?
Somebody help me.
Somebody help Jordan. You want to help? Because it's vertical angle with 4. Sure, that works. Okay. Nico, you want to tell me 5?
5 is the same thing,
110, and how do you know it's 110?
Because it's vertical. So what's that one?
Vertical with 3, sure. So vertical here, it's also corresponding with 6. It's alternate interior with 4. So all of those theorems and facts I just gave you help you to work your way through a problem to get the missing pieces that you need. Right? So the next one we have actually takes us into the algebra zone. So we need to take that. We're going to take those facts that we just learned and we're going to work our way through some algebra stuff in the next one. Right? Because we can't just let it go. There's all those. This one, I want to grab this one, bring it over so we can see it all happening. I need this clean spot. Please don't do that. Like, seriously, we don't need that. It's not going to help anybody understand. Okay, so we know that angle 1 in this case is 7x minus 15. Okay, we need to actually, our job is going to be to find x before we can find anything else. We know that angle 2, this is going to be a little complicated. We know that angle 2
is 90.
Is not 90, is 10 times x plus 11.
Oh, I mean, wait, which one is 90? Is the angle 6?
No, this one right here, the unnamed one. So we're gonna have to do a little bit of thinking through here, okay? Angle 1 and angle 2, they're not alternate interior, they're not alternate exterior, they're not corresponding. So we're gonna have to do a little bit of extra thinking to figure out the relationship between angle 1 and angle 2 in order to even get an equation.
Consecutive?
They're not consecutive either, so they're none of the special names. And we're going to ignore this 5 and 6 for a minute because we can't do anything with that. However, we can say, what's the relationship between angle 1 and angle 3? What's the name of it?
What does that mean?
It's con what? No?
Consecutive.
Consecutive what?
Angles?
Consecutive.
No, I wrote down.
Yep.
Go back, change things.
Consecutive what? Yeah.
He said it.
No.
He said
Oh, you said it? Consecutive interior.
Oh, I thought you said it wasn't one of the special one.
Can I see this?
1 and 3 are.
I asked
1
this
and
guy.
2 are not, but 1 and 3 are. So what does that mean about them?
I don't
Consecutive
know what to see.
interior angles are what? Starts
Supplementary.
supplementary. And what does supplementary mean?
180.
They add up to 180. So that means if I take angle 1 plus angle 3, I get 180. But I don't know about angle 3 except for I know about angle 2. How are angle 2 and angle 3 related? Vertical, which makes them congruent. So they're the same, right? So this is also the measurement of angle 3. So what I can do is I can take angle 1, which is 7x minus 15, and add it to angle 3, which is 10 times x plus 11.
You have to combine that like terms.
Is 180. Yeah, so this is algebra right here.
That changes.
Okay. We need to distribute this 10.
10x.
So I have 7x minus 15 plus 10x plus 110 equals 180.
What is the first thing say?
First thing is distribute the 10.
Okay. Now
we put the like terms together. 7x and 10x give us 17x. Negative 15 plus 110 gives us 95. That equals 180. Then what's our next step? Subtract 95. So 180 minus 95 is 85. Okay. And yes, you're allowed to use a calculator for that. And then how much is 7 when we divide by 17? 5. X equals 5.
Oh my goodness.
Now that x equals 5, we can use that to find out how much angle 1 equals.
Is this just
20
times 5 minus 15. 35 minus 15 is 20. So that makes angle 1 is 20 degrees. So now that we have that, we can do that.
61.
This one, angle 3, now that we have this, we don't even have to use plug in anymore. So this one, 20 and 3, angle 3, they have to add up to be 180, right? So how much is this angle 3? 160. 160. And you'll be able to replay this. Angle 3 is 160.
You mean like you're making a video?
Okay, yep. All right, so hopefully I can finish this off. So that means angle 2 is
160.
160 as well.
So that means 4 is 20?
4 is 20. 4 is 20 because it makes 180 here. Then we can work our way over here. How many degrees is angle 5? Forget about over here now for a second. How much is angle 5? Alternate interior with this one, so that's how many? 90.
Oh.
So this one's 90.
And angle 6 is 90 also, right?
5 is 90, 6 is not 90.
Oh.
But 6 and 1 make 90. So
70.
this one will be 70. Oh my goodness. Okay. So there we have all the different things. Pretty nice way that works out. And so what you're going to need to do by Friday is the assignment on that. Now, I'm going to end this recording.
No,
I
no,
want
no.
a soccer player.